Welcome to section 11.6, area of circles, sectors, and segments. Today we're going to look at how do you find the area of a circle, how do you find the area of sector shapes, and then tomorrow in class we'll look at how do we do the actual segment procedure, because I think it's a little bit more involved that it won't suffice for the video. So first things first, area of a circle. This should be familiar. We've done all this already before. Area of a circle is given by pi r squared, where r is the radius of the circle. The circumference of the circle C is equal to 2 pi r. R is the radius and C is the circumference. Now in a question in the future we're going to see where we have a diameter given to us. We have to first solve for the radius. Alright, so if we're looking at area of a circle or circumference, in general terms it's a good idea to solve for the radius. So let's do an example with this. It says find the circumference of a circle with area 100 pi square centimeters. So we're not really concerned necessarily about the units necessarily, but what I'm looking for is to actually find the number portion of it. So if I'm trying to find the circumference and I have the area, I have to work backwards from the area formula to find out what the radius is. So I plug into my area formula, which again is pi r squared for a circle. I plug in 100 pi in for the area. I set that equal to pi times the radius squared. So to solve for the radius, I divide both sides by pi, and I get r squared is equal to 100. To solve for r, take the square root of both sides, and I find out that the radius of a circle is 10. Now again, we're not complete yet because we want to take that radius and then plug it back into the circumference formula, because the question is asking us for what is the circumference. So circumference is equal to 2 pi r. We're going to take 2 times pi times 10, and 20 pi is our answer. We leave our answer in terms of pi because it says nowhere in the question that we wanted to round to the nearest tenth, hundredth, whatever. Alright, exact answers are preferred. That's area of a circle. Now for sectors, the sector is the portion of a circle that it takes up. So a sector of a circle is a region, so this region right here, this shaded area, that is bounded by 2 radii and an arc. So this is a radius, as is this. So these are my 2 radii, and this is the arc that's bounding it. So you guys might be too young for this, but there used to be a video game called Pac-Man. That's basically what we're looking at with sectors. Or if you think of it in terms of pizza, because pizza is very good, this is going to be just a slice of pizza. So we want to figure out what's the area of that slice of pizza in relation to the entire thing. So the area of the sector is given by this formula, the measure of the arc over 360 times pi r squared. Now let's dissect that formula a little bit so you know where those pieces are coming from instead of focusing on memorizing the formula. The pi r squared is the area of the entire circle. So that's everything all together. That's if we were to find the area of this entire thing. The arc over 360 tells me which part of the circle does this take up. So it's the fraction of a circle, the fraction of the area that it takes up will give us the area of the sector. So if I've got half a circle, then it's 1/2 of pi r squared, and that will give me my area of the region, of the sector. R is the radius, the measure of the arc is this intercepted arc here, and there is the sector, this is our shaded area. So as an example number 2, we want to find the area of this sector. This is all we're given in the picture, is that we are given a radius of 8 for the circle, and the arc that it intercepts is 30 degrees. So what we're going to do is we're going to take our 30 degrees and put that over 360. So it's going to be 1/12 eventually when we simplify that down. And we multiply that portion of the circle times the area of the whole thing, which is pi times 8 squared. So we take 1/12 of 64 pi, and when we reduce that down, we're going to take 64 divided by 12, reduce it down as a reduced fraction, and you get 16/3 times pi. Notice again that my answer is in terms of pi. I don't have any decimals anywhere. I haven't rounded anything. Example 3, I want to find the area of this sector. So again, the shaded area is that sector. So really there's 2 ways to do this, and one is I could find the area of the whole circle, and then I could find the area of this white portion of it and subtract it off. But because we already have this arc, it's easiest if we just do 225 divided by 360, which is going to reduce down to a nice number for us. It's going to be 5/8. And then I'm going to multiply that by pi times 3 squared. 3 squared being 9, 5 over 8 times 9 is going to give me 45 divided by 8 times pi. So again, this arc takes up 5/8 of the circle and multiplied by 9, 45 over 8. If you want, you can multiply all this together and then reduce the fraction, or reduce it here, then multiply and just verify again that it is reduced. Example number 4, we're trying to find the area of this sector, and you might notice that this sector is actually a semicircle. So if we were to find the area of that particular sector, we could take 180 divided by 360. It's going to reduce down to 1/2, and then multiply it by pi times 6 squared. Notice it's not 12 squared. The diameter is 12, not the radius. So the radius is going to be half of that number. So 1/2 of 36 pi will give me 18 pi. Alright, now my last example here is we want to find the area of this shape. And this is a combined area problem. We got to figure out what kind of shapes do we actually have in this problem, and how do we use that. So on this problem, I'm seeing 3 things. I'm seeing a rectangle right in the middle, and on either side of that I'm seeing a semicircle. Now those semicircles are the same thing on either side. So if I look at the dimensions here, I've got a dimension here of 16. That's also going to be the height of my rectangle, and my length is 20. So the area of the rectangular portion is 20 by 16, which is 320. If I wanted to, and I'm trying to do that because it says find the area of the following shape, I can add the area of the rectangle plus these two together, the semicircles, and it's going to tell me the area of the entire thing. Now because this is 2 semicircles, same dimensions, they're really, if I put them together, I'm going to get the same circle. I'm going to get one circle. So I can use the formula for the area of a circle, which is pi r squared. Because the height of this is 16, that represents the diameter. I don't want to use the diameter, I want to use the radius. So I take pi times 8 squared, which is 64, times pi. On the area of the whole thing, add them up. 320 plus 64 pi. It is not 384 pi. 320 and 64 pi are not like terms. You cannot put them together. Make sure of that. You do not want to put those together because they don't both have pi's. If they did, that'd be perfectly acceptable, but they don't. Tomorrow in class we're going to look at what is a segment, how do we calculate the area of that.